leaky sewers or some sort of like leaky local things was actually providing some dilution in summer months. So here's a question that I had as an undergrad at UC Berkeley. Can you swim in the bay here? Does anybody ever swim in the bay? Nobody. One person out of 100, right? So Berkeley's on the water. There's a beach right there. Does anybody swim there? Is it safe? When I was undergrad, there's a really cool thing, the Cal Sailing Club. I don't know if you've ever seen that. If you go down there, you can join for like $30 and you can learn to windsurf. And they have a whole bunch of windsurfers and you just like take a turn on a windsurf. We live in a place that's like impeccably great for windsurfing. I didn't become a great windsurfer, but you're out there windsurfing, you're learning to windsurf, and you fall off and you're in the bay and you're like, wow, I just put my head underwater in San Francisco Bay. Like, should I be worried? Is that okay? And then I would come back to Cal and people would be like, you just swam in the bay? Are you crazy? But we do have data on that, and it turns out it's totally safe to swim in the bay. People are measuring. There's Heal the Bay. You can go to Heal the Bay, look it up. There's the beach report card. This is all in Alameda. This is where there's a public beach with lifeguards, and it's like a big white beach with a lifeguard on the tower and little kids playing. And so that's where they measure. That's the one place. In Berkeley, it's not sort of considered as like a public beach. I sort of wish, instead of having 7 treatment spots in Alameda Beach, they would have like one in Berkeley and one, sort of spread it around a little bit more. The one place where we swim nowadays, we go to Angel Island, has some really nice beaches. And then you sort of feel like you're further away from the city. You're sort of like, the Richmond refinery is like over there. So Heal the Bay, it's a really big, it's a really big thing in LA with the Surfrider Foundation. They do a lot of sampling. People in LA are a lot more beach focused. LA has a lot more, beach as part of, sort of central. People in San Francisco go to the beach and they sort of like, whoa, it's too cold. But in LA, people are all at the beach. There's a report card, the top 10 beach bummers, what beaches are not safe to swim at, interestingly. Avalon Harbor Beach and Catalina Island, this is interesting. A lot of power boats go there, and the people on the power boat need to go to the bathroom somehow, and so somehow there's like some sort of localized pollution in this tiny harbor on Catalina Island. And then Cowell's Beach. Anybody been to Santa Cruz? Yeah, most people been to Santa Cruz. You like go to the lighthouse and you see the surfers down below the cliff. So one of these beaches here, Cowell's is the one right in the pocket. So the pier's out here, lighthouse is out here. Super famous place, like the classic place to learn to surf. Totally polluted. You can swim. It turns out on the beach report card, you can swim over in front of the the boardwalk in front of the roller coaster, or you can swim around the corner. But in this corner right here, consistently gets an F on the beach bummer report card. But there's an awful lot of surfers out here, right? Turns out there's a storm drain from the city, like right there, where like the river that runs through the city comes through. So especially after it rains, it's particularly the urban runoff is particularly polluting. Oh, do we have any other ones here? LA. So here's the windsurfers. The place where the windsurfers go. That's pretty polluted too. Yeah, they're windsurfers. They're these guys they're definitely in there. They're getting hit all the time. So those people, those windsurfers and those surfers, they're getting sick. Like they're getting some, some environmentally caused sickness. Yeah. Algae bloom. So the algae blooms do happen naturally, just with the different cycles of the summer and the nutrients coming and upwelling and stuff. So there are algae blooms that are natural. And then the interaction of algae blooms with human health is sort of difficult. Like some algae blooms are bad for people, and some algae blooms you can just swim in. This is this enterococci. This is more like, can we measure human pathogens in this water? So can we measure that, like, things that are infectious from human beings that infect other human beings? That's what we're measuring here, not other health effects. All right, let's move to air. The Clean Air Act, again, Richard Nixon, 1970, EPA starting. There's a lot of air pollution, a lot of water pollution. We're just getting begin in the 70s. We write the Clean Air Act. We give the federal government mandate to write regulations. Like the Clean Air Act, like the Clean Water Act, the Clean Air Act, it gets amended later in the 70s and 80s and 90s where, things are much further along and we have more ability to sort of narrow in on what sort of regulation. So in air quality, there's a lot of non-point source pollution. And there's a lot of, like, we're breathing it in all over the place. We're not going just to a river to swim in. We're breathing it in wherever we are. The federal government sets national standards, and then we set up regional boards, air quality boards, for sort of like ambient air quality to be measured in a regional level. We have a bunch of different point sources, chemical plants, electrical plants, steel mills. We have big industrial plants that we can clean up. We have a thing where states can have stronger laws than the EPA laws. That's been proven to be okay in court. California being a case in point. We'll go through that some more. California can have stricter air quality laws than the federal laws. The states have the mandate to enforce and monitor the laws that the EPA puts out. The EPA does regulations. They write national regulations. They do a whole bunch of science on how people are affected by different pollutants, but the states remain sort of the ones doing the enforcing. So California has basically two big ones, the Bay Area Air Quality District and the South Coast Air Quality District. We have, you probably heard of Spare the Air Days, where they're like, weather conditions and pollution is such that we're going to ask for people voluntarily to drive less, or we're going to make BART free or something like that. So that's sometimes when you hear about the air quality district. So in the air, what are the pollutants? What do we need to regulate? There's pollutants that cause, we've already talked about, there's pollutants that cause smog, like actual smog that we see that's visible. There's pollutants that cause acid rain, and I talked about this already, changing the pH of rivers and lakes and changing remote aquatic ecosystems. There's also a class of pollutants that cause toxic exposure in people. We can show cancer rates, asthma rates, other acute health effects, where we're going to say certain levels of these pollutants are going to be linked to certain health outcomes. And then we have a class of pollutants that was depleting the ozone layer up in the stratosphere. So we can say there's different classes of pollutants that we need to regulate. The primary standards, again, they're based on human health. This was like the swimmability. In air quality, we have affecting cancer and respiratory illness. The secondary standards are standards about the environment, trying to reduce acid rain or remain visibility or other environmental effects. There are 6 big pollutants that the EPA works on. The criteria pollutants, they're called. The first is particulates. Particulates less than 2.5 microns, PM 2.5. So this is an interesting thing where technology has evolved. So it used to be PM 10, particulates less than 10 microns. Then now it's PM 2.5, particulates less than 2.5 microns. It's a whole bunch of different small molecules that are caused by sort of reactions with sulfur oxides, nitrous oxides, sort of what comes out of a combustion process. We think this is one of the most important ones for human health effects. The other is ozone, ground level ozone being a big one. We have a weird thing with ozone where we need a whole bunch of ozone to be up in the stratosphere to reduce the sun's rays coming down, but we don't want ozone to be down at ground level where we're breathing it, where it can cause us health effects. And unfortunately, we can't get the ozone that we're breathing in here to go to the stratosphere very easily. We have nitrogen oxides and sulfur oxides, and then carbon monoxide, and then finally lead. So here's some propaganda from the EPA showing that basically the Clean Air Act has been working. Okay? So emissions have gone down. Carbon dioxide emissions have gone up a little bit, but not that much. But the 6 common pollutants, the 6 ones I talked about, have gone down, while population has gone up, transportation use has gone up, and gross domestic product has gone up. So this is the EPA saying we have reduced the amount of emissions, over the time of the mandate of the Clean Air Act. Over this 30 years, we have less criteria pollutants. Here's some sort of mathematical looking at that. This is sort of the data behind that one before, showing that the total amounts are going down within each pollutant. We're like tailing down. Nitrous oxides, sulfur dioxide are ones that we'll talk about a bunch in this class. We had lead in gas. We removed lead from gasoline, so that made that go down a lot. Carbon monoxide and carbon dioxide, we'll probably have to add to this, are still high because it's something that's really hard to remove if you're going to use fuel for transportation or for energy production. And here's the PM10 and the PM2.5. So for a while they were measuring PM10, then they switched to measuring PM2.5, but we've been able to reduce that a lot by changing car technology. So, and here we have, there are what we say is there are areas in attainment that are attainment areas and non-attainment areas. So these are, we divide up geographically and we show areas that are meeting air quality standards and areas that are not meeting air quality standards. And then we have within those groups how many millions of people are living in those. So these are, so that's a combination one at the top. So for ozone, PM2.5, sulfur dioxide, lead, nitrous oxide, the number of people that are living in areas that are exceeding the EPA regulations for how much pollution should be in your air quality. So, so it's certainly in the case of ozone, these are the people living in big cities. We have 120 million people living in a place that is exceeding the ozone standard for healthy living. So air quality's gotten a lot better, but we still all live in densely populated urban areas full of pollution. So still a whole lot of people having 120 million people with potential health effects from high levels of ozone. Here is a way to divide up what the sources are. So this is like power plants, industry, vehicles, like car transportation, and other sorts of mobile sources, like tractors and trains and things that aren't cars driving on highways. So we have the different pollutants and what their sources are. So some are largely from these stationary point source pollution, and some are from these mobile sources more. The PM2.5, one of the main ones that is still coming largely from power plants and industry, less and less from highway vehicles. On the top line I'm talking about, the red bar is very small, so we've cleaned up the amount of particulates coming out of tailpipes. These are within each class of pollution. So the EPA has a whole bunch of different things going on. There's multiple criteria pollutants, there's multiple sources, and there's different ways to go after each one of these. There's different ways. When I talked about cars, cars have standards. Tailpipes have different standards. Smokestacks have different sets of standards. Transportation I already talked about by showing you a graph of what the EPA puts out as requirements for new cars being sold. So we have national standards for auto emissions. We had a problem with air quality standards coming from a class of vehicles called light trucks. For a long time, light trucks were sort of exempted or had very much of a lax EPA regulation. They had less strict tailpipe standards, but people started driving a whole bunch more in vans and SUVs, which are in this light truck category. Now it's 50% of the vehicle miles traveled are vehicles that fit into this area of light trucks. We also have more people driving more miles every year, so the total number of transportation miles driven keeps going up, hoping this will turn at some point. And then the other thing we have is we have changing standards on fuel. So first, the most effective one was taking lead out of fuel. That wasn't like requiring consumers to do anything, requiring car manufacturers to do anything. That's moving up at the top to the refineries. Then we have requiring fuel blending, requiring mixing in some ethanol-based stuff, and that's been a big change. Now we have one that's low sulfur diesel. We're trying to get sulfur dioxide out of diesel fumes. So we have a whole bunch of ways that we can regulate up at the top where the fuel is produced before it gets to the pump. There are some toxics in air quality. Most of those other pollutions we wouldn't think about in the toxic category. Those are just sort of like gases and big pollutants that we have tons and tons of. But we do have airborne toxics. There is mercury that's released when we burn coal. There are industrial processes that release PCBs. Since 1990, we've been able to regulate sort of the major sources of toxic emissions, find these sets of factories that are creating toxic emissions, and put regulations on them. And this regulation, again, this one is a technology-based regulation. So you have a factory that produces plastics or produces spray paint or something. We're going to go there. We're going to look at what the best available technology is, and the EPA is going to require, like, you have to have this sort of capture hoods and this sort of, sort of flow out to the environment, go through these certain best available technology processes. In Berkeley, there's one that's always controversial. It's down by the freeway. It's the bottom of Gilman, and it's a steel foundry. And it affects the local air quality in Berkeley around the steel foundry. If you're on the highway going by, you can see it, or if you're at the bottom of Gilman, you have these blue things on the top of all of the buildings. And it's like an air system that's ducting the releases from all of their buildings in the foundry to some area where they can process it all. So that's sort of one where you sort of visibly see it as you're driving by. Like, that's some best available technology that they've decided to put on it. But these are big chemical plants, paper mills we talked about with ammonia, big refineries we have a lot of in the Bay Area. And then we have particulate emissions going to PM2.5. The 10 most polluted cities in the US, an awful lot of them are in California, right? So California is a leader in air quality problems still. They were in 1970 when it all started. They have been throughout. And what's a big deal now is sort of where LA was number one. Now we have Bakersfield, Visalia, Fresno. The San Joaquin Valley has taken the lead into bad air quality. And it's a little different. So LA has a whole big structure in place of what they're doing. But you can go up day by day. So this is colors didn't come out very well. So this is Bakersfield here. But you can think of, we have the Bay Area as an air quality problem. We have the San Joaquin as an air quality problem. We have the South Coast integrated air quality problems. Here's some of the big cities, the Arizona, Houston, going up the eastern seaboard. This is from when I was teaching the class before. Unfortunately, I looked at today's forecast. There wasn't as much air pollution, so it was going to be harder for me to show the air region. So I had to use some old ones. Interesting, up here in Redding, there's some problems. That's sort of like probably from a winter condition where stuff gets trapped. But Bakersfield, you can breathe in Bakersfield today. So there's real-time data, though. We have sensors out there in the environment giving us real-time data that we can, the regulators can use. Here's LA and Bakersfield being the big area. All right, I'm out, so you can.